Hey there. So, our level renderer is coming along. Got water and grass. Going to be implementing the trees and rocks today. So, let's dive in. The new tile types are going to go in the tile folder. Got grass and water there. In our index, you can see that we still have a lot of undefined tiles. Rock is up there. And where's the trees? Right there. They're both just generic tiles with the map color. So, let's do this. Need a rock tile, and we'll need a tree tile. And they're going to be a lot like the grass tile, not exactly the same. Let's see. We'll just start with the constructor. Make sure we get the right map color in there. For trees, that was down here. What's that missing? Let's see. Type is not a constructor function. Oh, for some reason that tile import isn't being like it should from, like it's not importing correctly from the index file, but that's okay. Need the rock tile. And that is right here. Okay. And then we've got to use those implementations in our index. Rocks and trees. And then, of course, make sure the whole thing still works. So there's the trees, the dark green blobs. Let's find some rocks. There we go. That grayish color right there is where the rocks are. And I want to swap this around just a bit. Use our palette to get the colors. Gonna guess at a color that will look correct. And same for trees. Alright, the tree color looks about right the same. Of course, now it's using the correct palette. And there's the rocks right there. May look about right. Uses that same palette for the level generator display. Alright, the next bit, we're going to have to convert some Java. Just a second while I load that up. there's the Java class for trees. And then get the Java class for rocks. Like I said previously, I'm converting all of this from the Minicraft Java project, which is open source, but it is, like I just said, it's all in Java. Java and TypeScript aren't too dissimilar. Alright, so for the tree tile, trees do connect to grass. I'm trying to actually re-implement a lot of this stuff as is reasonable, if I think I have a better implementation. But some of this rendering logic or like gameplay logic, it just makes more sense to like translate the Java code directly. All right. So let's do this. Just copy and paste to that entire function signature. And I need a reference to level dirt color. Am I using that elsewhere? I'm actually using it right there. Level dirt. It says dirt color does not exist on the level. That is suspicious. Oh, it's importing the wrong class for level. Let's try that again. The equals function just checks to see if the tile ID, if the two tile IDs are the same. But then, why is that an error? This is not assignable to parameter of type tile. It should be. Okay, I'm going to ignore it for now. I think that problem might just work itself out. Oh yeah, I forgot the. There's two function signatures for the hurt function, which gets a little weird with TypeScript. We'll get to that in just a minute, though. We need some sort of implementation from the mob class. All right, so one mob class coming up. And that's all we'll need for the moment. Let's see, level XY damage. So this is calling that. It needs to be implemented differently to properly work with TypeScript. Level needs a get data and a set data, which should not be hard to implement. In fact, Amazon Q might write it for me. Thanks, Amazon Q. Cool. We still don't have the ability to add things to a level, and we don't have particles. I'm going to go ahead and implement what we do have here. Oh, come on, you. Alright, so we have those references. I don't think we have resource yet, do we? No, we have resource item, sort of, but not resource. So I'm just going to comment this bit out for now. you look at how to bring these bits together. So level XY damage, and we have level XY source damage and attack direction. So the thing is, TypeScript is really just JavaScript in a fancy suit. You gotta remember that whenever you are implementing something like function overloading. Gotta think about what's that gonna look like when it compiles down to JavaScript. Both functions have level XY, and then source, the source, which is a mob up here, and damage down here, so this needs to be source or damage, and mob or number. And then the rest of the parameters are just completely optional. So, see if I can do this right. Oh, just gotta think. If source or damage, instance of mob, let's see, how do I want to do this thing? In C++ or Java or C# operator or function overloading is fairly simple. Kind of wonder if it's even worth it in TypeScript. Once you have it in place, it's useful. Can I do that? No. But I can do this. It's not a mob, so the source or damage must be a number. So if source or damage is not a mob, then it must be the damage value. We're going to assign that to the damage value. And then down here, we're going to assume that the damage value is in fact defined. In neither case does it even use the attack direction. The only reason we're leaving it is because it's required by the tile class. Black return type annotation, so we need to tell that it returns a void. And I think that will do for now until we get more of this implemented. those function signatures are going to go into the tile class. And I think I'm going to try to make this a little bit easier on us. So tile can be hurt two different ways. Either by a mob, or it can just be hurt randomly, I guess. We're going to have two protected functions. And hurt mob goes in there. Hurt tile goes in the other one. That little exclamation mark says, like, if something is possibly undefined, we're going to make the assumption that it definitely has a value, which I believe is safe in this case. Oh. There we go. So I'm going to handle all the function overloading as its own thing up here. And then down here, how does that help us? Undoing all this for reasons that will hopefully make sense in a minute. Make all of that go away. And there. We can still call the hurt function the same way as the Java code was expecting, but all the icky details of overriding, having multiple overloads for that function are going to be hidden from wherever that function is being consumed. And then up here, for rendering these rocks, for one thing, we're using the tile set render function. for another thing, we have two types of inputs. This is the X and Y pixel position where we want to render, and then the camera is going to translate that from world space into screen space. We need the tile position for interacting with the map. That needs to go into the levels get tile function. And then we need these four sets of coordinates translated through the camera. And the tile set render function has the tile index as the first parameter. Because it just made more sense to me at the time, and I'm not changing it. Been thinking about it. I'm using a vanilla two-dimensional canvas, like web canvas, for rendering this thing to the screen. It gives me great performance on this laptop, but lower performance laptops struggle just a little bit. I'm thinking about trying again at implementing the WebGL canvas, so that'll probably be coming up soon. Alright, now we plug these coordinates into the renderer. Next is the top right, I believe. And I just did top right on all of those. That was a little silly. Okay, this one should be bottom left. And then finally should be bottom right. And I need to reformat this or it's going to drive me nuts. I like my curly brackets. Keeps me organized. Being organized is everything with this work. Alright, I think that does it. Let's clean these up. Just disabling the warnings that really those are going to stay there whether the linter complains or not. Bits for now, and comment out this bit of tree tile because I want to see if I did the rock tiles correctly. Let's find out. All right, here we go. Moment of truth. Oh, do you see that? Some weird warping at the bottom, like at the very bottom edge of the screen. But we do have rocks. I'm gonna have to run some tests on the tile renderer to see what happens when it reaches the bottom edge of the screen. It's like it's not clipping it the way it should. Alright, so that's cool. Let's look at the tree tile. Same treatment as rock tiles. Ignore the errors for the moment. This one is the overriding the hurt mob function. Which a lot of times is getting the same type of override every time. So I'm going to make that the default. Which will allow us to pull it out of the rock tile definition. Yay. Just made it better. Interact, which does not have a definition yet. Let's see, that's the hurt tile function. So let's define interact. That function is getting trucked over to the base tile class. Why is that giving an error? Because we imported the wrong level type again. I don't know. I started using Pinot for logging, but I'm thinking I might use a different library. I'm not sure yet. Need the tiles collection. And yeah, just going to comment this out for now. I converted the bits I can, and then we will clean up the rest later when some of these other classes are implemented a little better. So trees have 3 different color sets. I think this can just be copied and pasted. A lot of this logic here is getting reused every single time, so we might be able to simplify this a bit more later. Anything where you're typing the same code over and over and over again, you can probably type differently. Alright, scooting the tile indexes over. We are almost done. And then we need these positions. Okay. Turning off warnings as needed. All right, let's see what we got. Hopefully we have trees. Something's wrong here. They're rendering, but not the way I expected. Alright, let's take another look. we have the TypeScript code on the left, the Java code on the right. Comparing the up, down, left, right values, but I think those are right. Correct. I wonder if I copied these correctly. No, I think this part is correct. So something else went wrong. 10, 9, 10, 10, 10, 9, 10, 10. Over here we have 10, 9, 10, 10, 10, 9, 10, 10, and 1, 0, 2, 0, 2, 1, 1, 3. 1, 0, 2, 0, 2, 1, 1, 3. This is bottom right, I think, because we're adding to the x and y values. This should be bottom left. Top right. Top left. Oh, it's the knots. There's no knot. This is not a not equals. I need to take off these knots. That would do it, I think. All right. And those are good looking trees. Still got a rendering bug there, which we have not looked at yet today. I don't think I'm going to tackle that right now. It's weird that it's not happening with the trees. It's happening with the rocks, and I think it's happening with the water. That's a little suspicious. But I think I'm going to tackle that in a separate video. But this is looking good so far. I'm happy at least. I think we're going to stop it there for today. Congratulations on making it this far, if you're still following me. And yeah, make sure to hit the like and subscribe to continue this adventure with me. Hope to see you next time.